These days, we're becoming more and more accustomed to watching and reading about multi-million-dollar mission launches into space. But still, every once in a while, there comes along a landmark launch that promises to truly change what we know about the solar system and the universe. The James Webb Space Telescope is one such mission, and after years of delays, it is finally getting off the ground. This is Unveiled, and today we're exploring all you need to know about the James Webb Space Telescope. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. The James Webb Space Telescope, also more simply known as the Webb or the JWST, is a joint initiative by NASA, ESA, the European Space Agency, and the CSA, the Canadian Space Agency. It's making headlines in 2021 as its launch date nears ever closer. But work on the Webb actually dates back to the mid-1990s, more than 25 years ago. Back then, it was more broadly known as the Next Generation Space Telescope. But it was given a name change in 2002 in honor of the one-time NASA administrator James E. Webb, who oversaw NASA during a crucial period between 1961 and 1968. It was initially billed as Next Generation, though, because it was then, and is still now, seen as the direct successor to the Hubble Space Telescope. The entire world knows how successful Hubble has been over the years, so Webb certainly has a tough act to follow. So why has it taken so long to get to this point of launch? And what can we expect from Webb once it is up and running? Well, it's no secret that this telescope has had its fair share of the space technology version of development hell. Over the course of its history, there have been manufacturing delays, ballooning cost issues, and a noticeable rethink to the entire mission in the mid-2000s. The machine we have today, however, has been ready to go since 2016, but various issues have come up during preliminary testing and practice launches, all of which need to have been safely and officially ironed out before it launches for real. There were 2 delays announced in 2018, the entire project was put on hold during the pandemic in 2020, and then there was the canceled launch in October of 2021. But all signs are that the time has finally come. But really, whenever it leaves Earth for the sky above, Webb is set to become one of the most impressive, important, and exciting machines that the world has ever known. The mission should last at least 5 years, not including a 6-month commissioning phase right at the beginning. But those in charge are hoping and aiming for at least double that, and a 10-year mission duration, or more. Over that time, Webb has 4 main mission objectives, according to NASA: to learn more about the earliest stars and structures after the Big Bang, to study how galaxies form, to study how stars and star systems form, and to search other star systems for signs of life. If all goes to plan, it will achieve all of that from a position close to the L2 second Lagrange point, which is a region in the solar system almost 1 million miles away from Earth in the exact opposite direction to the Sun. This means that Earth will always be orbiting in between Webb and the Sun, and the telescope itself will always be looking outwards into the rest of space with our star behind it. Out of interest, by comparison, Hubble is a lot closer to home, orbiting Earth as it does around 340 miles away only. On board Webb, there will be all manner of cutting-edge technology. Although the vehicle itself will weigh roughly half of what Hubble does, its primary mirror, a spectacular-looking golden structure of 18 interconnected smaller mirrors, will fan out to more than 5 times the size of Hubble's. This will allow it to literally see more of space than ever before. But also, its specific design will enable it to view the universe across a different and wider section of the light spectrum. Webb is primarily an infrared telescope, and while Hubble has some capabilities here, it will better its predecessor considerably. Webb will also stretch out into mid-infrared range, picking up extremely faint, never-before-seen light from across the cosmos. Crucially, Webb's infrared effectiveness depends on the telescope itself being kept cool as minus 223 degrees Celsius in fact, because otherwise the heat from the machine itself will mess with the measurements it can take, and Webb will fail in its goals. To keep at such a low temperature, the telescope itself is fitted with a state-of-the-art sun shield, which also serves to protect it from any other nearby sources of heat or light that could cause similar problems, such as the sun. The sun shield is then quite a feat of engineering and is described by NASA as being 5 layers thick and about the size of a tennis court. The unfolding of the sun shield once Webb reaches its target location will be a crucial moment in the mission. At launch, it will be tightly packed to ensure a streamlined payload. But then, when it arrives at its eventual home hundreds of thousands of miles away from Earth, it will fan out, and hopefully without any problems. Incredibly, some components of the Webb will still require extra cooling to perform, even after the sun shield, but the sun shield does the vast majority of the work. Elsewhere, Webb is loaded to bursting with high-tech gadgetry, cameras, spectrographs, and detectors, all designed to peer out into space with better precision than ever before. Working in the infrared spectrum, it's expected that all of the many images that Webb will process should be less affected by the gas and dust which typically cloud our view of the universe. This means that Webb should be far more sensitive to far fainter signals, meaning it should pick up colder and smaller objects than most other machines, at hopefully much greater distances. This is fantastic news for the study of planets, for example, both near and far, which tend to be, for obvious reasons, much less visible than the stars they orbit. It's also potentially vital for the study of star formation, though, which often happens in amongst enormous cosmic swirls of previously impenetrable debris. It's hoped that Webb might even be sensitive enough to monitor specific weather patterns in detail on planets that aren't Earth, and perhaps even on exoplanets that aren't even in the solar system. Of course, whenever a new mission designed to look out into space is launched, one of the first questions leveled at it is usually, will it discover aliens? And while the search for alien life isn't the primary goal for Webb, there are reasons for SETI enthusiasts to follow it closely. Thanks to those infrared capabilities, Webb will not only be able to view more of space physically, but it should also be able to look further back in time, toward the very first stars and planets that formed anywhere. This means that scientists should be able to build both a more precise map and a more precise timeline than ever before, charting the rise and fall of systems, the spread of matter, and the differences and similarities between different parts of different galaxies. Again, this probably won't directly result in the discovery of aliens, but it will better inform scientists of where to look with the best chances of finding them. Ultimately, whether it's aliens, exoplanets, far-off stars, or close-up galaxies, Webb will be providing so much of our space data in the coming years. And as space travel booms in the private sector and space agencies around the world race to improve their knowledge, the coming years could well be some of the most crucial and influential in the history of human space exploration. There's really no underestimating the role that Webb could play. So best mark your calendars for launch. When Webb does go up, it will do so on board an Ariane 5 launch vehicle, with a reported cost within the region of $10 billion by the time it leaves the ground. This massive, potentially world-changing project was begun in the latter years of the last century, but it could become an iconic mission in this one. It'll be a few months even after launch before Webb starts sending images back to Earth. But when it does, we can expect those images to outshine all that have come before them. The universe will never have looked quite like this. And that's all you need to know about the James Webb Space Telescope. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.